everyone. I assume most of you are online because you're not here. So, hi. We're going to look at the top of this page. We're going to look at the top of this page. Just the top. This bottom part we will do later. So just this part. This last section is on mathematical modeling, which is kind of, we've been doing it all along. But we are taking real world stuff and moving it into math world so that we can kind of figure things out. And then we take our results back to real world. So, some important steps in this is to, they're in this box. Identify variables. A variable is something that changes. So, anything that's an amount that isn't always the same, that's important, is variable. We also need to decide, this isn't necessarily one of the bullets, but as we formulate our model, which a model could be a table, a graph, a tree diagram, an equation, as we're formulating our model, we need to decide what things are important and what things aren't. So, if you're modeling COVID cases in nursing homes, then maybe you would decide how often they eat mashed potatoes is not an important thing. And so you say, we're going to ignore this, we're going to assume this is not part of it. If later you do your model and you get results that don't seem to match, like something seems off, then you think, well, maybe one of those assumptions that we made about things not mattering, maybe some of those things do matter. Maybe the mashed potatoes do matter. So things that would be variables might be, well, things that would change. Maybe the number of visitors that are allowed, or the number of staff members that rotate through, or whatever. We've got to decide what's important for my model and what's not important for my model. What things change and should be a variable, what things are always constant, and they're just a number in there. Then we perform operations, which could be as simple as reading a table. Like you look at the table, oh, there it is. You just performed all the operations. Or maybe it's a really complicated formula and you have to put in 20 variables and calculate it all up. Either way, you use your model. And you look at your results, your math results, x equals 7, y equals radical 3. And you take that and go back into the real world and say, okay, what does this say about the real world? And then validate conclusions. We want to say, did this model seem to fit or not? If it didn't, we need to change the model. And that's the whole, this whole section. That's the focus, is modeling. But in order to do that, we're going to need to access some of our algebra skills, which is why the homework we had leading up to this class, why we had so many review things. So, once again, I know you know this, because you were here. Oh, it's not on here. Because it's not on. Huh. A lot of things due today. Oh, zoom in. We had the 5.2 class section and the 5.2 group section, and on Blackboard, don't know if that's going to focus in or not. As you try these problems 1 through 17, if you find that you've got some holes in your info, you should watch the video Nerd Study Intro to Linear blah blah blah, which is this one, and so on. This 5-2 group section, if you struggled with some of this, you want to watch the slope-intercept form video right here. So those people that Algebra 2 is real fresh, maybe they could just skip those videos. But today, we're going to use stuff in the folder of Things Due Monday.
That's not the right folder.
Nope, it is not the right folder. There we go.
That's what I needed.
Nope,
It's like 11.
it's 11 for today,
4.
so it would be 11:09. There we go, it's purple. So this first thing right here is this. And we're not turning that in yet. We're just looking at the top. I put 2 things on there because I wanted to save paper. We're going to go to the Graphing Stories activity. So that is this, and it's stapled. Do you have that? Okay. So we are going to watch this clip and graph what's happening. So on this graph, there's time on the bottom, and then we need to decide what's going to be up here. So on this side will probably be height, probably. So we're looking at how high this guy's waist is off the ground, and that's what we want to graph. I feel like there would be music with this. Be better. Maybe like Mario music. So notice how when he sits there, he's not moving, but time is still moving. That's why we have this flat place right here, because this is time. He stands at the bottom for a little bit. He's not moving, but time is moving. He steadily climbs up. His waist gets higher and higher. His waist is the same height for a while as he's walking across the platform. Then he sits down, and he sits there for a while. So I'll pause that if you want to draw it. If you are watching this video, I would suggest that you watch the real videos instead of this video of the videos. Like, I'd maybe pause this video and go to Blackboard and actually watch it for real, if I were you. Because a video of a video. It doesn't have to be beautiful. So this is a model, mathematical model of what really happened. It's waste over time. Okay, so next we want to do the ponies in frame, number 2 problem. And I am going to pause it at 1:13. So if you're doing this at home, it's on the paper. You'll see it. Where to pause it. Oh, okay. Nope. Still. So by in frame, we mean we can see the ponies. Okay, so I'm at 1:13 and I'm pausing, and we are going to try to graph that thing. So you ready? Rewind it. Okay, so we start off with 1 already, right? Let's fast forward to half speed. There we go. Okay, so 1 second in. We see 2 ponies. And what happened going from even before we get, I'm mean, we start with 1 on there, but before we even get to the 1 second mark, or maybe just right at the 1 second mark, she opens her hand and we see that second pony. So the third pony looks like it shows up around 5 seconds. Fourth pony is at 9 seconds. Let me know if you need me to slow down or go back. Okay, so at 13 seconds we don't see any ponies anymore. And let's see. 14 to 15 we saw 1 again. Okay. Whoop. Ready for the answer? Apparently, they are not counting his hands covering it as being 0.
I was gonna say, cause I did not look like that.
How did yours differ? Where is it?
On the ending, it like dropped away off.
Yeah, I think if I'm doing it,
Mine dropped off at like,
I'm gonna put it 0 down
because
here.
9 was the last time, like at 9 seconds was the last time I seen one. And then
So,
it kinda
like-
just dropped off down to nothing.
Right here, he's covering all the ponies. I would have put a 0 line down here.
Okay, that's about where I had mine at. About 11-ish.
So apparently, whoever made this answer thinks, oh, it still counts, they're still there even though his hands are covering it. I kind of think, we could argue that. I just leave it how you have it. I think yours is great. And as we're doing this, it's not like, we're not sending a rocket to the moon with these. We're just kind of practicing. So we can kind of chill a little bit. Okay, so on the worksheet, it says so the second graph, if you felt like your first graph was way off, then I would say to do the second graph to kind of get the real answer. But if you think your first graph is pretty good, you could maybe just like draw a line and say, mine's good, the first one was good. But that little arrow bit, note the discontinuities in this graph where it jumps from one height to another. So what that means is, from this thing right here, it hops up here. Like there is no line connecting it. Why not? The last one there was a line, like when he did the height of his waist.
Like, that was one thing moving constantly. These are different things.
Yeah, there was no
Each
like,
individual thing is their line.
yes. There was no 2.5 ponies. It was just either 2 or 3. So sometimes our graphs will be continuous. That's a math term. And sometimes they won't. Okay, flip the page and we're doing water volume Okay, so 112 is where we want to pause this one. Pause this and point out the shorts shirt combination here. That's a pretty crazy outfit choice in my opinion. Okay. So after we see at half speed, this is where we want to like try it on our own. Don't we rewind it to the beginning of the half speed? So at 0, our volume is definitely 0. Okay, it looks like at 2. Is it reaching that 50 line?
I can't really tell, but
At 2, I think it was a little below the 50. At 3, it's kind of in between the 50 and the 100. But would you say that she's pouring, or he is pouring it at a constant speed, or does it look like it's varying?
it's very.
Once it's more full, it's easy to see the water level, I think. So 14-ish, it looked like we made it to 600 milliliters, around there. Got your best guess? One thing to think about is, will this one have a continuous line or will it have jumps?
I think I know
How did yours compare?
about the same.
Great.
I don't know exactly, but
Yeah, that's great. Do I have 2 of those? Oh, no, that was that one. Okay, so at the bottom of this page on Blackboard is the website that these came from. And so for the 4th one, you're supposed to pick one. Any of them you want. Write down which one it is. Pause it before the answer and give it your best guess. And then Write down what they say it is. Doable? Okay. Next, this is all in, zoom out some more. This is, all of this graphing story stuff is in the subfolder. But additionally, what we are going to do over the weekend is there's also this linear, exponential, quadratic, cut and paste activity. This is this page. What you're going to do is cut out all these squares, get 3 pieces of paper, and at the top of one piece of paper you're going to write linear, then on the second paper you'll write exponential, on the third paper you'll write quadratic, and then you're just going to tape or glue which piece goes with which thing. So you'll have a page that says linear at the top, and you'll have some of those squares taped or glued on that are all things about linear equations, and you'll have one for quadratic, and you'll have one for exponential. That is all described here, hopefully clearly. And then you're going to take pictures of those 3, and I would recommend hanging on to those things because it will be helpful to study. It might be a good idea to use tape or rubber cement, something that's removable. So later when I give you the answers, if you want to like move it from page to page, you can. If you glue it with like an Elmer's glue stick, it might be impossible to remove. So there's these 2 videos about quadratic relations and exponential functions. The ones that you supposedly watched before today are all about linear. So if you need help with linear, you can go back to the stuff that was due today. I can open the right folder. These 2 are about linear, if you need it. The new ones for today are quadratic and exponential. And that's it on the homework. And then the last thing I want to do is go over questions from the homework. So, you on the video, hi, if you have questions, email them to me, and I'll try to help you. Bye!